we good? All right, we will go ahead and get started. Welcome to today's class. Again, my name is Debbie, and today we're going to be talking about composting. And this is a project that we have going up at Masonic Homes there in Union City. So when you are driving down Mission Boulevard or sitting back at your schools, you can probably look up at those East Bay Hills, and between Dry Creek and Masonic is where you will be able to see the area that we are working on. So you may see some of our tractors going back and forth. You may see some big piles of compost that are up there on the hill. And that's the project area that we're working on. So again, if anybody has any questions, you can always email us your questions. And we will try to get back with you. And again, if there's anything that you need printed out, that's where you can also reach that. And again, we're not quite sure what we're going to be doing this summer. We're going to be running some special event things, probably at like Tule Ponds, where we open things up so everybody can walk around and see some stations and all, see what all is there. All right, so today's idea of composting, the key concepts, we are going to be looking at how compost is created. And in our compost, we are using food waste, and then we add horse manure and wood chips. And that's how we create our compost. And we are going to learn how these organisms promote composting. We're going to learn that the compost helps grow healthy soil, helps put those nutrients back into the soil. And it's just a matter of movement amongst the matter amongst the plants, the animals, the decomposers, and the environment. So as you look at this food that is rotting, it is not a pretty sight, is it? Okay, and this is another reason we have the project there at Masonic. All right, now we are going to look at this bowl, and I want you to make your guess and predict which objects are going to decompose first, like which ones are going to fall apart first and which ones will be last. All right, you ready? You got your guesses? We've got grapes in the middle, apples, some three red tomatoes, looks like some plums, a cucumber, sweet potato in the middle, some squash, some bananas, peaches, strawberries, and then two more little cherries. And I believe those are some shallots, kind of like an onion. All right, here we go. Make your guess. Ooh, strawberries. Lots of liquid. Our peach is gone. Oh, tomatoes. Okay, what's the deal with that tomato in the back? How come it didn't go at the same time? Okay, look at the difference. What's the difference in the apples? Oh, look at that back tomato. It's bubbling. Oh, there goes our banana. Oh, finally the last tomato broke down. Oh, our squash is looking kind of thin. Look at the deal with the back tomato still hanging in there. Oh, there it finally goes. Oh, there goes the zucchini. Now, what's going on with the potato? Oh, squash, yellow squash is kind of the last to go. The shallots are still doing okay. But what's happened to the potato? Everything else is rotting, but it is growing. That's a starchy vegetable. So that's big. Potato is a food source. So that's giving that plant plenty of food for it to grow. Now, that's kind of crazy, isn't it? When we talk about how foods decompose, did you make your guesses right? Did you guess that the strawberries would be the first? And it was kind of crazy the way those different tomatoes went in different orders. Okay, let's look at this. I'm just going to turn it on real quick. You see how soupy, how the soupy those get. Oh, and the peach gets soupy real quick. Have you ever done that when you've reached into the fridge and you found like a cucumber or something or a zucchini that you forgot about and it gets all stinky, smelly, and there's a lot of moisture? Well, that's where it's coming from that plant. But now look at the difference between those two apples. Maybe one of the apples had kind of the wax coating on it, so that keeps it preserved more, so it keeps it from getting bruised. I don't know. I don't know why that back tomato did so well. Again, maybe it was a different kind, different food source. Maybe it had been straight from the garden, hadn't been harvested as long. The other apple again finely turned. Again, those shallots that are in there are kind of like that potato. Those are food sources for that plant. So they will eventually start to grow. Have you guys ever had an onion maybe that's been sitting around and all of a sudden it starts with the green shoots, just like this potato is starting? There's the first little bud coming out of the eye of the potato. Here goes another shoot up. So again, those are a food storage for that plant. So that's why those foods are going to grow. They're not going to rot. If they were in a bag all enclosed, they might rot. And then you'd probably get some bugs too. So again, when we just have food like this that's rotting, it is usually smelly, stinky, and it attracts bugs. So we want to figure out how we can use our food sources, our food waste, and have it decompose without making a big smelly mess. And the way we do that are by using different techniques. There are two major types of composting, and that's hot and cold, okay? If you're using cold composting or cool composting, it takes a long time and you have to have a lot of space, because basically you're just mixing in this mixture and it has to sit there for a while, and it has to be turned and rotated, and it uses some of our larger organisms to break those things down. Now, the second way is much faster, and that's the way we use up at Masonic, and that's the thermophilic. That's hot. So the temperatures get really high, 140 degrees, and it gets so hot that that creates an environment where we have different types of organisms, like your actinomyces. Doesn't have like your big worms and things like that, but your smaller organisms that are going to help with that decomposition. So this is up actually at Masonic Home. So if we can get you guys up there, this is an idea of kind of stuff you'll be looking at. This is a giant pile of horse manure or compost there. And again, all we're doing is taking small samples and looking at it. And when it's great compost, it just smells earthy. It doesn't smell. All right, why is compost important? For a lot of reasons. It helps our environment. The biggest thing is that it reduces the volume of waste. Okay, if you guys think about just your own, like say what you had for breakfast, did you have anything left over? If you had a little bit of oatmeal or some toast or something like that, if you have a dog, then you may have given it to the dog. But otherwise, those crumbs, those bits end up in the trash. They go to the landfill. Right now it goes to Newbie Island. Food waste goes all the way with trucks. It's trucked all the way over to Altamont. So again, that's a big carbon cycle. There's a lot going on there. What we're trying to use is the food waste that's generated right there at Masonic and keeping it local and reducing that waste volume. Instead of having to send it out to the landfill, we can take care of it there at Masonic. And then that compost is going to help fix our soil. It's going to give us better soil quality so that we can plant more trees. Again, it puts the nutrients back into the soil. All right, so here's a little poem called Compost Breakdance, and it has a lot of information in there, and Dr. Joyce is going to be narrating some of it. So here we go.
This is a poem called Compost Breakdance. It shows little organisms are eating and dancing and having fun as they break down food to produce compost for us. Cool composting starts organic matter in a heap, food waste leaves at least 1 meter deep. This slide is showing us that a traditional way of piling food and leaves and letting the organisms slowly do their magic. They need still air and moisture. The bad thing is that it releases methane, which is a greenhouse gas. There are many pathways different organisms take. The product compost is what they make. Cool composting takes time to collect. Organisms eating creates this brown effect. So as this is going through their system, they eat, they poop, and then the nutrients they get from what they're eating gets kind of put in their poop, and then as they're going around, they're making tunnels, and they are mixing it, creating that brown effect. Other cool decomposers, ones that you know, pillbugs, ants, millipedes, help plants to grow. So there's other organisms that are involved. This is a millipede here. As it's going through, as you can see, it's making air spaces, and so as it's eating, it's producing our compost. Annelids such as worms, important to be found. Long poop trails nourish soil underground. If you look at this little picture, that worm is pooping. Food goes in and poop comes out. So it's like a little chemical compost factory. And if you look on below, the little black spots tell you that's poop. And so they're aerating and pooping and creating that compost. A decomposer's dream is to break things down, whether hot or cold. They make food brown. So this goes back. They're always working. They're always doing their job. Hot composting is needed if you want compost quick. Heat produced by microbes is the chemical trick. Thermophilic compost. Actinomyces produce heat. By munching on nutrients, nitrogen, carbon are a treat. Now, if you look at this little organisms, the little pink things are the microorganisms, and the orange. And what they're eating is they're taking up nitrogen and carbon, and they're reposing it into other useful parts. Many medicines produced by actinomyces, a bacteria in hot composting, giving off heat as it eats. Actinomyces are responsible for the earthy smell. Composting is complete and all is well. This picture is showing some of these microbes. These are electron scanning microscopes, so they're very small, but they are doing their things. Many, many medicines do come from these little organisms. A decomposer's dream is to break things down, whether hot or cold. They make food brown. Again, still doing their magic, even as we are reading this presentation. Decay produces nutrients, whether hot or cold, available for other plants, microbes, and mold. So a lot of this material that they're composting and breaking down, the nutrients and the elements are available to the plants which need them to grow. Compost by itself is not enough. Must be mixed with soil to make magical stuff. Crushed rock and organic matter makes rich soil. Compost is nutrient rich, not just food to spoil. So remember that, is that you just don't put food waste. That will produce anaerobic composting, which just stinks and is not good. So you need to follow these methods that we'll be discussing later. Decomposition is essential to the entire food chain. Dead things are broken down. The life cycle can sustain. So this is not something just minor. This is an active part of all the life cycle. The little ones have to help support the larger as you go up the food chain. A decomposer's dream is to break things down, whether hot or cold. They make food brown. Sing it with me. A decomposer's dream is to break things down, whether hot or cold. They make food brown. Now, this is the essence of our presentation. Decomposers of compost. All of these animals throughout the food chain have their purpose. But remember, this is a food web. It goes in many different areas. The little cards that you have will help you try to figure this out.
All right. So, and this is one of the sheets that you can download, that you can print out. And it's just a fun, kind of gives you an idea of all the different types. And again, we've got our hot compost and our cold compost. And we're going to be getting a closer look at those and those cards here in just a second. All right, this is a big pile of basically leaves, a few little branches that were chucked up, and Dr. Joyce want to take a closer look at it, but it was basically just leaves that were piled up. And let's see what's happened with it.
This pile of leaves almost looks like an erupting volcano as the smoke comes up, telling us that there's some heat in there. If you put your hands inside, it's warm, and that's because the little microorganisms are doing their job, eating and releasing energy, and we're seeing it as the creation of smoke.
Okay, so again, there's not an ignition point. There's not fire that's starting that's making that smoke. What's actually happening is those microbes are breaking things down. They're generating heat, okay? As they generate heat, then the water that's formed on the outside is due. That's where that steam is coming from. So again, this is just created by those microbes breaking down this little wood pile, this pile of leaves, okay? So that this is actually creating steam from the microbes. All right, looking closer at this soil.
This is looking some more at this compost. We can see the red worm, which is a native worm to California. And we also notice just lots of other bugs just rolling around, doing their magic. You can see the ants. As he's pushing it around, you could see a lot of things moving. The ants are bigging, I think that ant is moving, and Poopa, we must have disturbed a nest.
All right, I talked a little bit about that earlier when we were waiting to come on. We talked about how an adult ant looks like this. Then there are eggs that are laid. And sometimes when you disturb a nest, you will see them moving the eggs. Then we do have the larva that, again, a little bit larger. But what we're seeing in this picture, that little white blip, is actually a pupa. And inside is where it's turning from that larva into what we would see as the actual adult ant. Okay, so again, first thing to notice when you're outside is, again, look where your feet are. You want to make sure you're not standing in the middle of an ant pile. All right, but again, all of these different organisms serve a purpose. Now, if you look at this, we've got a big old earthworm. And you see how, remember, we mentioned that we put in a lot of the wood chips. Okay, we have a kind of real clay soily up there that gets real impacted, and it's hard as concrete when it's dry. And then when it's wet, it's, super soupy and slippery. So this little earthworm, to be able to survive there, has to have some good little air pockets. So as it's burrowing through the mud, it's creating some of those air pockets, but these little extra wood chips are going to help that a little bit better versus just the hard clay. It wouldn't have as easy a time. And again, if you are not a worm person, that's great, but there are so many different kinds. I have a big pile of some dirt here with some, again, there's all different kinds of worms. This is like a big giant earthworm. The red worms that you saw, again, are different. And again, the ones that you use for composting, again, are also a little bit different. So many varieties of worms. All right, so when it comes to the food chain in our compost pile, if we start at the bottom, we're talking about the leaves, the grass clippings, plant debris, that's like old roots, your food scraps, the poop from dogs, cats, other animals, the worms, even like we saw, animal bodies, soil invertebrates, all those things will go into part of that O layer, part of that organic layer of the soil. Then we've got our primary consumers, our first level. And those are kind of those roly-polies, the bacteria, you see the actinomyces. The next group, you're getting into your larger, like your beetles, your larger organisms like these. And then finally you get to the tertiary group, the finest top level, and that's going to be your carnivores, like your centipedes. You may not have ever thought about how a centipede is actually a carnivore. So if you've got centipedes in your house, that means you do have a pest problem. All right, so these again, all organisms that serve a purpose in breaking things down. All right, so in converting our organic matter, again, ants, number 1, fungi, you see the picture of number 2, all different kinds of fungi. Fungi sometimes only live for an hour, sometimes they can live for weeks. Number 3, again, you see the worms. It's a nice beefy earthworm. Bacteria is number 4. Again, usually you would have to have a microscope to be able to see that. And number 5, that actinomyces, and that's what we have with our hot compost. A lot of times people will see it that it looks kind of like mold. They think it's like a moldy growth and they think the soil is bad and they throw it away. That's the good stuff. So when we know we have actinomyces, we know we have a good, healthy soil started. All right, so again, this is the sheet that you can print out. It's in the directions with those cards. And as you look through this, you'll see the 2 different areas. We've got the hot compost. So in hot compost, we only are going to have the actinomyces and the fungi. Because remember, we're getting up to 140 degrees. So our earthworms and our beetles, things like that, all those things are going to be killed off. That's also another reason that it's good, because it will kill off any bad bacteria and bad eggs, things like that. When you've got the cool composting, remember it takes a long time over space, has to be turned, but that's where our larger organisms come in, like our beetles, the flies, the millipedes, the slugs, the snails, okay? So again, a little different between those 2. All right, so when you have these cards, if you want to go out and go looking for some animals, that's great. If you do not, then you can use like your little plastic organisms that you might have sitting around your house. We talked about the grasshopper and the cricket earlier. How about things like your arachnids, your spiders, again, many different kinds, okay? And even things like these, kind of an odd shape as well. So you can use just your plastic bugs to look at things. We talked about how you can find dead bugs and see if you can find those. Look again in your windows, screen porches, like in the back of your cars, like along the car windows, things like that. You can usually find those. And again, that's a great way to study them because they're already dead and they lay still. So you can look at them closely. All right, so here are the directions on making these compost cards.
For our decomposer cards, you're going to need this Decomposers of Compost. This is again a sheet that your teacher can print out for you. This shows you the whole complex web. And then you'll also print out some individual sheets like this that give you a graphic of the animal and then a small description. Now on this sheet, you're going to cut the strips straight across. So I've done that, and you're going to put it on a card so that it wraps around. So again, the picture's on the front and the description is on the back. So you can see here, I've cut one of these out. So I've got both of the animal and the description. And then I'm just going to put a little bit of glue. And right at the fold is where the index card can go right there at that fold. Fold it over just like that. And you've got a card. Now, if you'd like for these cards to be secure really well, if you're going to have them outside a lot, you can also cover them with like the clear packing tape. Just simply put a layer over it and another layer over back here. And now with these cards, you'll see that you've got quite a few of them. It's a good thing to keep them all together in a bag. That way I can just throw them in my backpack if I'm ready to go hiking and want to look at decomposers.
Okay, so again, you guys have, if you're back and you're working together in your classes, you'll have these all, everybody's got a bunch of cards all spread out. So you could either do like a color code, put the same color on the whole set, or put your initials on the end so that your whole set's identified so they don't get mixed up. So you have a complete set. But again, if this is just to give you an idea. So if you saw an animal like this, you might recognize that it is indeed a springtail, and our information tells you a little bit about it, that it's an arthropoda, but it also tells you something important, that it jumps, okay? So it's giving you some clues also to kind of what to look for, all right? All right, let's keep going. All right, so again, you can use your plastic models to help identify, or you can just go out and roam around and see what you can find. All right, when it comes to cool composting, now this is where we are looking at layers of vegetation and the pre-existing soil.
It's our cool composting area. Art is getting ready to move it over to the other area, so then we can have a lot of good compost. So, but this cool composting, this has been here for over 2 months now. You can see it's still kind of dark and it's still very good, but it took us 2 months versus 2 weeks.
Okay, so again, cool composting, that would continue to get turned, and again, would take quite a while. But at Tulip Ponds and the California Nursery and all, we don't buy soil, we make all our own soil. And so we start off with just the parent material, just the crushed rock, and then we add the organic matter. And the organic matter is going to be parts of this compost, as well as these fine little organisms that we're getting in there. So this is a kind of a cool compost bin that you might have at home, and it would require constant turning and mixing. So this way you see that it's got, you know, the layers of green and layers of brown. You can put everything in these except for proteins, except for meats. That cannot go in there. But if you mix it and you layer it, kind of like lasagna, if you layer it correctly and it's got air circulation through, it doesn't attract flies, and it makes a great additive, makes a great compost. All right, so that's the cool composting. Now this is using some more to make it more of a hot compost. All right, this is using a composter that's at Tulip Ponds, and Art is showing you a bin of some food. So we use those little coffee, just because some of our people drink a lot of coffee. Those little coffee bins with the lids, those make great home food bins if you want for your food waste. They also make something like this. It could even just be a small little bucket like this, so that you put your food waste in. And they make even the little compostable kind of bags as well. So if you wanted to create your own, start saving some of your food waste at home, if you've got a small area you could put it, that's great. Hopefully maybe we'll be able to get a food waste system set up where we can do neighborhood pickups, because we need more food waste up at Masonic. All right, let's see what happens here with this chemical mixture.
Now we're going to make some compost. Art has food waste in there. So notice we have 1 part food waste. So he's going to dump it into the container and he's going to get it all in there. Then the next thing, so that's our food waste. That's providing nutrients that we're going to break down. But if we just left it in there, it wouldn't work. We need a source of nitrogen. And so if you look at this, this is our horse manure. So he's going to mix that in with the food waste. Then the other thing it needs is carbon. So we use just plain old wood chips. It has to be small, can't be large, and he's going to dump that. So this is our 1 part food, 1 part horse manure or nitrogen, and 1 part carbon. Then we're going to, so Huggis, do you want to bring that a little bit so I can see the inside of it there?
Remember that yummy
So if you notice in there, it looks just brown. Yeah, but you can start seeing the food waste. We're going to add a little bit of water and then close it up and then aerate it. So we're just going to put a little water in it and we're going to close it down and we're going to let chemistry do its magic. So we're going to have to aerate it, and that's what Hagos is doing right now. And we'll be, and within a week to 2 weeks, it'll be ready to go as the compost that we've seen. Thank you.
All right, so that compost again was being thermophilic. It was a smaller composter, but we were able to get the right mix, and we get it at a real high temperature. So that speeds up how much time it takes for that decomposition, for all that food waste to break down. And again, we're breaking it down so that those nutrients can be released back into the soil. So again, thermophilic is super hot. Then it comes back down to meso, which is kind of in the middle. So it has, once it's cooled down, then we know that it is almost ready to use. So this is again,
we're turning the compost in there to get the air in the area. Now we're going to stop it. So stop it, and then we're going to open it up. So open it up.
And this is after about a week.
And when we look inside, there is lots of compost being created. Now we're going to take the temperature of it, and how we're going to do that is Art's going to put in the thermometer, and we can start measuring the temperature. So it's cooled off, so now we know it's ready to go.
All right, so we do have to monitor the temperature of our piles, because once the temperature starts getting up to 140 degrees, we don't want it to go higher than that, because that's actually then gets too hot. It will kill those microorganisms that we want and can actually start a fire. So again, we've got to monitor those temperatures, and we turn and aerate the piles. And then as the temperature comes back down, that means it's all done kind of cooking. It's all those microbes have already done their work. All right, so again, after 2 weeks in the composter, this is what we get.
We're going to dump the compost that we just created, and we're just putting it in a container. And then we're going to bring it, Art's going to bring it to the pile that we have, an active pile that we mature the areas to. So let's walk over with Art and let's see our compost pile over here.
Remember, that's where he was.
So as we walk in here, he's going to dump it in, and it will stay there for about 2 months, and then our compost is ready to be used.
So most of those little white chips that you see are eggs, because we use a lot of eggs when we're cooking. Those take longer to break down, but again, the calcium eventually does get broken down. But you see how it just takes time, though, to do this smaller zone composting. All right, here's a clip that I filmed when I was back in North Carolina to give you an idea that it doesn't matter really where you live, you're still going to have decomposers, and you're still going to have that process happening. Okay, you guys are real dry in California. So again, things are a little bit different. We have a lot more water in North Carolina, but again, it's always the same. So let's take a look.
To go.
Okay, so for some of our materials that you might need today, you could use a shovel or a little trowel. You could even use a spoon or fork or knife. I do have some plain index cards and some tape. And if you remember from last week, we also have our insect identification cards. So we're going to be using those. So your job is to see if you can take a hike around your neighborhood and see what you can find. Look at the different types of soil. So I'm going to dig right here. If you look at this big leaf pile and stick pile, this is an old garden bed where we had some flowers that were growing, and we just covered them up with all the sticks and the leaves. Let's see what's happened. Come on in here. Let's see. So if I dig down, move these leaves. Oh, look at what I'm starting to see already. Let's see. We've got some worms. Now again, worms can't hurt you. They don't have little mouths that can get you or anything. So you can find those in your, so this is where you'll use that classification chart. We'll see what things we can find. Now if you look at this soil, so this is that same parent soil. It's got a lot more organic matter in it, compost and all, but you also see all the roots from the trees and the plants that were here before. So again, there's some rock that helps with the aeration. But again, we've got a lot of organic matter in here. Oh, let me snap this little one. Oh, did I get him? Oh, here, I'm trying to find this little roly-poly. There he is. There, that's a little roly-poly or a pill bug. Those are actually crustaceans. They have gills, so they have to be where it is a little bit moist. So that's why he's like here in the shade underneath all these leaves and all. Again, these are great little pets to have if you want to make a little terrarium and keep these in there. A lot of people that have other pets, they'll use these to clean up after their frogs and turtles and all. All right, let's see what else we can find.
I'm sitting here watching your guys' faces, and some of you guys are cringing.
Now you won't find any, you won't be able to see the funguses, bacteria, those things. You'll just see some of the larger animals. And now you also, if you've got a hand lens, something like that, you can also use that to help look for things. And you can, if you find something, you want to put it in a little tub, you can do that as well.
You can just look at things with your
looking.
hand lens. You don't have to pick them up if you don't want to. I saw some of you guys cringing and stuff. Remember, my background is forestry and wildlife management. So I'm always going to go for things and pick things up with my hands. But again, if that's not your thing, you can simply use a hand lens to look. All right, here's another idea. I moved this hose out of the way, and this is what I found.
Here we are again at another part of the garden that has a fair bit of organic matter. And you look at the profile here, just a little bit of the soil that's on top. See how these are little chunks? Okay. Now we also have some other organisms here. Now again, real easy thing to do is just simply put it in a little top like that.
So you don't have to
now look at your cards, your insect classification cards. We included ones that are not necessarily insects too. See if you can figure out what this one is.
You guys know what that is?
I love these guys. It's kind of cold here again, so it may take them a minute to wake up. Kind of
They're so cool. They're
my favorite. You guys know what this is? Yeah, it's a slug. It's like a snail that doesn't have a shell. And if we can get him to wake up, he's got some antennas. Oh, there his antennas are starting to come out.
Slugs really are one of my favorites.
So again, this is one of our larger decomposers.
But it was cold when I was filming this, so it's
no, we just pulled it back in.
Taking a little longer for it to settle in. So again, you always want to return any organisms that you find back to their original location.
Okay, on your insect identification cards, there's also a snail. So the soft squishy animal is inside that shell. The animal is the one that makes the shell. As it grows larger, it makes a larger shell. And again, it's similar to the group of the slugs, where it is simply a decomposer. So its job is to break up all this leaf matter, make little holes in the ground so there's more air to get through, leave their little poop trails. I'm going to put my little slug back down in here because again I want him to stay where they live, because this has got all the things that he needs to live there. I don't want to take him away from his home. All right, so again for this soil you can see it's pretty crumbly. So it's the red mud with a little bit of organic matter. You see the big leaves and all in there, but it doesn't really stay together. It's not very moist.
Okay.
Okay.
That is very similar to the soil that we have up at Masonic Homes. Now you got to remember, back in the Spanish invasion, back in the late 1800s or early 1800s, Spaniards came through. They chopped down all the oak trees. They didn't know that those were slow growing trees, and they needed those resources for their housing and for foods and all. So unknowingly, when they chopped all the trees down, those tree roots were then holding the nutrients in the topsoil. Where did all that topsoil go? Down into the valley or blew further away. All right, so now we're going to take a look up at these East Bay Hills and get a closer look at what we're doing on this project. But I want you to think about how these hills used to look like before even Masonic Home was built. They were covered with oak trees. Okay, so there was a lot of vegetation there. And now let's look and see what we've got. So again, this is a great video that was put together, composting at Masonic Home.
The inspiration for the restoration at the Masonic Home was an area that the Math Science Nucleus works with Alameda County Flood Control and Water Conservation District, called Tule Ponds at Tyson's Lagoon. Our role in the Masonic Restoration Project is to coordinate the science to make it work. The long-term goal is a complete reforestation of about 1,000 acres, and that includes the Masonic Home, Cal State East Bay, and possibly East Bay Regional.
We have a new reforestation program in partnership with TriSed and Math Nucleus. And that partnership is bringing back some of the native species to the hillsides. So we're planting trees on the hillside, and we're using that soil amendment to help those trees grow.
started to look at using food waste to accelerate composting. So we looked at different machinery to accelerate it using thermophilic composting, which means getting your food waste in a closed bin system to increase its heat and creating compost much quicker than you could naturally. Carbon sequestration is a process by which you're holding carbon into the soil and it's not released to the atmosphere. Using the food waste and not putting in the landfill, it basically prevents the creation of methane. You're also creating horse manure, which is providing nitrogen, and you're not allowing that to release as methane. And so you're making a mixture that's enriching the soil and getting the nitrogen into the soil, the carbon into the soil, and you're creating just an excellent blend between preventing those methane gases, the greenhouse gases, from escaping and creating an area that will later be able to support trees, which the soil right now can't support the trees because it's been devoid of decomposition for years.
My name is Manuel Gallardo. I'm the executive chef here at Masonic Homes of California. We do approximately 900 meals per day, times 365. All of our waste product goes into the bins. Scraps, everything except hard bones. So from here, it gets taken downstairs by our crew, and then somebody from Tri-State comes and picks it up and takes it all the way up to the top. And then they bring us back clean, empty bins. And that happens 6 days a week. I would say that we're probably down 50 to 60% by composting rather than filling up trash bags.
We've saved quite a bit of money over the years that we've been doing this program, as our food waste is no longer being moved into our landfills. And our residents have really been actively engaged in the entire process. They're part of the farming and they're part of the byproduct of the farming, and they're enjoying this as well. This is actually the first Masonic home in California, and the building was built originally in 1892.
Been here in our family since 1917, but actually started with John Rock in 1884. He was a German immigrant that came here in the 1850s and was involved in our Civil War.
John Rock was a master mason. John Rock was instrumental in the landscaping initially for the Masonic homes and provided all of the trees and all of the shrubbery currently located here.
Well, after John Rock, my grandfather became interested in the property. In the course of the transition, selling of the property to a developer, the city preserved some acreage for a park, and eventually it turned out to be about 21 acres, which is what's here today.
Yeah, so right now we have about 30 acres that we are going to partner with Dig Deep Farms. And those 30 acres, we will probably begin with a 5-acre parcel and probably expand quickly to 10 acres. And those will be planted by our partnership with the Alameda County Deputy Sheriff's Association.
So working with the Masonic Homes of Union City has been a great opportunity for us. This is some of the last fertile flat land on the bay side of Alameda County, and is just a golden opportunity for us. It'll allow us to increase the amount of produce that we are cycling through our program, increase our sales, provide more employment opportunities for the youth of Alameda County. It's just a wonderful opportunity. We were searching for a way where we could make an impact on economic development, and we created a social enterprise called Dig Deep Farms. And we were able to secure several grants, employed folks from the ages of 16 up to the ages of 40. One of our chief goals was to be able to link those folks coming through our clinical case management program to jobs in the urban agriculture, local food system world. And we've been reasonably successful doing that. And the opportunity to bring the compost that's being generated from the food waste out of the Masonic homes and use it on our farming operation is a wonderful environmental opportunity. It's a opportunity to do an urban closed circle farming operation to sell produce back into the communities that are food deserts within our community. I think is a unique opportunity.
So what we decided to do was make compost, make piles, start mixing it in the soil, leaving it fallow for about 2 years, and then starting to put trees that we started here at the California Nursery.
Today, we're going to just try to put this road in so they can haul the composting stuff up to the top of the hill. It's probably going to be one of the biggest restoration projects in Alameda County.
So for the hillsides, we see reforestation as an important byproduct of what we're doing in these programs, and we'll be able to see the fruits of that labor hopefully in the next 10 to 20 years as we see those trees grow on the hillside. I think it's been a great partnership to be able to give back to the community and to be able to be more conscious about the environment here.
Project. And that quote that was last included there had to do with a pretty powerful quote, because I've been working on this project for a while, and a lot of the trees that I'm planting now, I'm not going to live to see them grow, get to be as big. You guys will. All right. So now we're up at the top of the hill, and you can see San Francisco off in the distance. And as you look back into these East Bay Hills, most of the trees are down in these deep ravines on the backside. And again, that's because they're sheltered from the wind, okay? And those deep ravines are where there's gonna be a little bit of water. Where we're trying to plant is the front side of the hills, and it's very harsh. You guys know how fast your winds blow? Well, they blow, super fast up there. So that makes it a little bit harder as well. But as we look across this, you see that we've been piling up tons of our compost. There at the bottom, you see Mission Boulevard, and that flat land there had been recently plowed for hay. So you see, again, there's a lot of construction that had been going on there. We're looking out now kind of onto Dakota Road, down back where you see Coyote Hills off in the distance, getting to move over towards the California Nursery and Niles District, and Quarry Lakes are a little bit further to the left. Again, you can see the bay, and then you see the mountains as you head towards Santa Cruz. So again, what we're trying to do here is mix in the compost to the parent material that's already there. We add in the wood chips. We believe the wood chips is helping us retain some of the moisture as well as give it some airspace. So as the soils mature, they will be able to support life. All right, so composting again is just a part of the life cycle. Now I've got some really gross and grody pictures here, but they're so cool because they explain the process. Let's start the one on the left, all the fruit. You guys ever had a peach or a plum, something like that, and it started to grow the fungi, the mold that would get like real fuzzy looking? Look at how there's so many different kinds of molds and all there. It's fun. Look at this orange. Again, I talked about how the flies lay their eggs turn into then these larvae that are making a mess there. They're getting rid of that orange. Even something simple like the leaf. Look at how the leaf is basically just degraded down by those microorganisms till it's just kind of a skeletal form. And even then the roots then further tear that apart. And then even our live organisms, once they pass, again, we need our microorganisms, our larger organisms that cause this decomposition that break things down. Okay, so it's important, again, to be able to break things down. So if we were talking again about the food waste, even at Masonic, we were talking that they do 2 tons of food waste a week, 2 tons a week, okay, that comes to our little composter rather than having to take it somewhere else. And there's a horse barn right next to us. So if you have just one horse that say weighs about 1,000 pounds, they are going to make 60 to 70 pounds of poop, of horse manure per day. Okay, one horse, 60 pounds per day. That means one horse in a stall, like in the little wall things, if it's inside the barn, one horse is going to make about 12 tons of stall waste a year. All right, that is usually then carted off. If they take care of it on the farm, sometimes it's just buried, but that creates methane, which is not a good greenhouse gas effect. So again, by adding all these things that are normally hauled off into the landfills, we're again be able to keep it close, limit our compost or limit our carbon cycle, keep it all within one particular area, improve that soil. And you see how many different careers are involved here. So it's engineering, it's soil chemistry, it's biology, it's botany, it's entomology. All these different sciences go into this. And it's all just about talking about decay, decomposition, that it also emits the greenhouse gases, but the trees then use those gases. So eventually that whole area will become a big carbon sink where the trees and the soil will hold all of that carbon dioxide and help us with that.